Anyway, welcome to April's meeting. We have some quick little housekeeping here. Housekeeping. It's housekeeping. I'm sorry. Nobody used to watch Family Guy. All right. So welcome again. Thank you for everyone that's new. Who's new? Raise your hand if it's your first time. Woohoo! All right. Well, welcome. And please make sure you say hello to Paul. And I know there was somebody else, but again, this light is shining right in my eye. I'm sorry, I'm a Luddite when it comes to this stuff. The one thing during the presentation, Mike, you're good with, Mike is going to speak. And if you have any questions, hold them to the end. That would be really great. We're here to celebrate the Hubble, and we've got some really good presentation. We have people on Zoom. So if you ask a question, we're going to give you the microphone so that they can hear too. Right? I forget anything? Oh, safety. What's important? Let's not get hurt. So here we go. Identify room hazards. There's cords. You can trip over your neighbor. There's probably purses on the floor. Just be careful. Watch yourself. People at home, don't trip over the dog or the cat or the lint on the rug. Let's see. Ooh. Who does CPR? Does anybody have CPR besides? Oh, we got some new people. Good. Because I know we need somebody to call 911. Dana, let's see, the fire equipment. There's a fire extinguisher over there. There's exits over here. There's exits over there. Yes. Make sure you have your trays in the upright position. Okay. Yes. Stow all your gear. Okay, so and we know where the fire exit is. And I'm sorry that it says current on Explorer on 4. They use that room for rental, and sometimes we get bumped, and we just happen to. They had set up for tomorrow. So next month we'll be back up there. But this actually is the correct emergency exit. You can use the emergency door, but please don't do it to make an exit, because what happens is the fire alarm goes off and everyone gets really upset. So please don't do that tonight. Just go use the elevator, you know where the restrooms are, and the emergency exits. Oh, yes, don't forget the key of shame over there, the big bone. Because if you lose it, it's a shame, and occasionally it gets lost. All right, we've got some upcoming events real quick. We'll talk more. Tomorrow, Wild Ideas Expo. We're going to do solar viewing at the Museum of Art. RAC Ops, which is next Friday night. I will put out an email this week because I'll be this weekend. I'll be looking for key holders. That will be Big Woods, Hal Woods, and 3BA. RAC class, sign up. Anna has a little flyer that'll come up later. Herring Front Yard Star Party. If you were there last year, we have a front lawn. We have parking for 18 people, and you're welcome to come join us. 18 cars, yes, not 18 people. In fact, we'll talk about that later. Go ahead. Wake County 4-H Sky Discovery Night. What else we got? Apex Friendship Elementary, statewide Star Party. If you have not signed up, check to see if there's any openings. It's on the calendar. It'll be a fun night. And tonight's presenter, whoa, Mike Keefe. I don't know. Mike Keefe, our one and only RAC astro nerd, is here to give us a presentation on the Hubble. And he asked, I didn't have to read, he didn't ask for me to read. I asked him if he wanted me to read that.
Yeah.
That's true. Copyright is always good. I agree. All right, so let's give this to Mike. You don't want to hear me talk. I'm ready to do Hubble. Oh, sorry.
All right. Sound check. You guys can hear me? Good. All right. Thank you. All right. I will share. All right. So we do that. Hubble Telescope. Has anyone ever heard of who the Hubble Space Telescope is named after? No. And of course, this thing's not working. Okay. There we go. Now my advancer is not working. Right. No. Okay, so it's a very famous telescope, right? We've seen it in terms of We literally have photographs from Hubble that have been parts of art. It's been in our news media. We've got some Lego toys, by the way, right up there up front. That is not a handout. That's not a giveaway. I'm taking that home. Uh, it has basically become part of pop culture. You see it on T-shirts, and we won't talk about the quality of this movie, but it's been in a movie. But what do we know about Hubble? And it's not just the name of a telescope. It's actually Edwin P. Hubble is basically the namesake of that amazing telescope. He was born in 1889 and passed away in 1953. Um, he got his undergrad from the University of Chicago in 1910. Interestingly enough, his father really, really, really wanted him to pursue law. So he went and got his law degree from Oxford. And then he said, yeah, no, I think I'm going to come back and I want to focus on astronomy. So he got his PhD 2 years after that from University of Chicago. And then life kind of got interrupted. So interestingly enough, he was actually a major in the United States Expeditionary Forces during World War I. So after that all happened, he got back to astronomy. And one of the amazing things that we know him for is that he discovered these Cepheid variable stars in the Andromeda Nebula, which we know is now the Andromeda Galaxy. And basically, using the work of Henrietta Leavitt Swan, deduced that these variable Cepheids were not in our galaxy. Amazing discovery there. He's also known for the Hubble tuning fork. So this is a classification of different galaxies. So you basically have your ellipticals, and then they'll kind of break off into your spiraled and barred spiraled galaxies. So he came up with that. And he also came up with Hubble's law. He did not name it that, but it is what we call it, and that basically means that he discovered that galaxies that are further away are actually moving away from us faster. So there's a relationship between their distance and the speed at which they're receding from us. So that was the namesake Edwin P. Hubble. What about the actual telescope itself? Well, size-wise, it's the size of a bus. Um, yeah. And in terms of what it actually, some real dimensions on it, it's about 43.5 feet long. At its thickest part in the rear, it's 14 feet in diameter. It weighs in at about 27,000 pounds, so a bit of a lightweight. And sorry, it's okay. In terms of some of the parts of the telescope. You've got the optical tube assembly, so very much like what us as amateur astronomers understand. We've got our OTA. We also have some support systems and different modules that are part of that, including the comms. You've got a lot of the equipment that is situated and covered by the aft shroud, and then solar panels and so forth. And I'm trying to keep it going fast because I don't want to miss splashdown. So I'll take a pause real quick. If someone watches that and just kind of gives me the heads up to say we're getting there. Okay. In terms of orbit, so it actually circles the Earth 15 times a day. It's orbiting about 340 miles above the Earth. And what blows me away when you really think about it, it's basically going around 5 miles per second. So I think of that as like something that's moving that fast. How do you keep it pointed at stuff? I know I have a hard time when I just get a little bit of a breeze with my 11-inch SCT. In terms of power, it actually, from its solar panels, it's able to generate a little more than 5,000 watts of power. Good news is it only consumes around 2,100 watts. Problem is, solar panels only work during half of its orbit. And I'm sure y'all can figure that out eventually why. So it does have batteries. It's got 6 batteries, and it's approximately a little more than 500 amp hours of juice. I know some of us have campers that have more battery power than the Hubble does. So I'll talk a little bit more about the battery and exactly what conditions can cause the hairs on the back of NASA's neck to stand up with that. In terms of science and observations, it has made over, and these numbers are from about March of 2024. It's made over 1.7 million observations. It has observed over 108 million objects. And you're going to be like, well, hold on a second. It's only made 1.7 million observations. How can it observe 10 times that or 100 times that in objects? Because you see lots of objects in one observation, i.e. the deep field. But only 0.1% of our skies have actually been photographed and observed by Hubble. Think about that. Not even 1%, 0.1% of our skies. Its furthest observation is 13.4 billion light years ago, or that's how far light had been traveling for, or how long, excuse me. And about 1,000 proposals a year come in to use either Hubble data or to actually use the telescope itself. To date, again, this is March of 2024, around 21,000 peer-reviewed papers have been published off of Hubble's discoveries. In terms of the designs, some of you may notice or recognize this design, but basically the light comes in, it's bouncing off of the primary mirror and then hits the secondary and then goes back into the instruments. So this is actually the largest Ritchie Creton, I know it's a French guy, that's ever been made. And it basically, it's 2.4 meters in diameter, a little less than 8 feet. It captures 40,000 times the light that our own eyes do. Its secondary mirror is 12 inches. My telescope's only 11. So yeah, I mean it's a beast. We've got, like we mentioned earlier, we've got its equipment bays here, as well as some of the instruments coming in. And in terms of what some of those instruments do and what wavelengths it's looking at, actually, we'll talk about the instruments first, but I'll kind of just list them here. But we basically have a bunch of them that they're set for different wavelengths of light. So we've got UV, we've got kind of broad spectrum sorts of things, and so forth. And this is currently what's on Hubble right now. So you'll notice that the near infrared camera, that is actually inactive now. It's no longer being used, but it is still on the telescope. So this is the current configuration and will be the configuration until it finally meets its end. So in terms of kind of the light and what some of these instruments do, so we know that our eyes are able to see a very, very small part of the electromagnetic spectrum, somewhere between 400 to about 700 nanometers. And if you've recently had cataract surgery, maybe you're a little bit further, into the 300s. But in terms of what Hubble can see, and now we're basically now looking at the entire electromagnetic spectrum on the left-hand side. We still have kind of what our eyes can see in the visible range. And here is what Hubble can capture. So you can see here are all the different cameras or basically the pieces of equipment and where they specialized in terms of what sort of wavelength of light they could gather. Obviously, right now, we really don't have anything on Hubble that does this kind of mid-infrared. Good thing we've got James Webb. So timeline. This is for 1923, so this is before anything had ever been put into orbit. Um, there was a German scientist who actually mentioned that putting a telescope in space would be a perfect place to get our observations. So that was the very, very first reference to a space telescope. And then in 1943, Lyman Spitzer actually wrote in one of his papers about the benefits of putting a telescope above Earth's atmosphere. Why the Hubble is not called the Spitzer, not really sure, but it wasn't my job to name it. So in 1969 was actually when the National Academy of Sciences actually got together and said, you know what? We need to make sure this is now part of our decadal survey and kind of moving forward. This is a science objective that we need to pursue. In 1975, the European Space Agency said, hey, we like that idea. We'd like to join you in that. So they agreed to provide 15% of the funding as long as they got to use the telescope 15% of the time. Now, in 1977, Congress says, hey, we like that idea. Let's go ahead. Let's go ahead and pursue a large space telescope. Now, in 1978, they actually start the grinding of the mirror. So this is a picture from Perkin-Elmer. So they start grinding the telescope. Now, at the same time, or really just after it, in 1979, NASA begins training for servicing missions. So a lot of people are under the misconception that, oh, Hubble wasn't supposed to be serviced. It was supposed to be fine, and we created these servicing missions after we found out that there was a flaw. But no, there were servicing missions planned all along, and they began training for them as early as 1979. Now, I think the next one's 83. So in 83, that is when the Large Space Telescope was officially named the Hubble Space Telescope. It was expected to launch in 1983, but as we know, any projects that are funded by the government never go on time, and they never are to budget, or always over budget. Fortunately or unfortunately, we have January 28th of 86. We lost the Space Shuttle Challenger. And at that point, all shuttle launches were grounded. That also wound up meaning that the Hubble was grounded. But finally, in April of 1990, we got to put Hubble in space on STS-31 aboard the Space Shuttle Discovery. There's a very interesting story. I talked a little bit about the batteries. There was an issue with the solar panels being deployed, and they were getting so ground control was basically getting this signal that's saying, the particular motor would not go further. It was stuck. Now, at this point, Hubble had been decoupled from power from the space shuttle, and it only has a certain amount of power on board, basically those 500 amp hours of batteries. And it does take a fair amount of wattage. But they were very much at a point where they were going to completely lose the spacecraft because it was going to basically go into a full power shutdown with no ability to have any battery power to keep it warm, and the solar panels would not be able to be deployed. And basically, if I remember the story correctly, one of the controllers on the ground said, yes, just ignore the alarm and push the button and force the solar panels open. And it worked. But rather than being a rather simple procedure, I can't remember exactly how long they expected it to take to deploy the Space Telescope. It took somewhere between 6 and 8 hours, if memory serves. So it was a bit of a nail-biting experience, and literally almost lost the telescope before it could actually observe a thing. Then we get the first images. So first images are basically telling us that, yes, this telescope is amazing, and it's actually 50% sharper than any images we can get on the ground. Hooray! Then we find out Okay, we're not getting exactly what we wanted. So obviously, there was a certain amount of configuration, just like we saw with James Webb. The very first pictures weren't perfect. So there was some tweaking. But then in June, they realized, yeah, it was not manufactured to the correct specifications. The variance is only 2 microns, 1/50th the width of a human hair. Yes. Are we coming in? 10 minutes. Okay. Sorry. Um, Now, again, a lot of people have this misconception that now we've got this big old paperweight in space doing nothing. But for 3.5 years, it actually did science. They were still able to do science. Roughly 1,200 papers were submitted with data from the Hubble telescope prior to its first servicing mission. So it was still active. Then we have our first servicing mission, and at this point it was Endeavour. There were a total of 5 servicing missions planned, each of them called like SM1, SM2, so forth. So there were 5 spacewalks totaling 35 hours and 28 minutes. That's what I call a full week's worth of work. Um, so that was December of '93, and then in January, here we go with the new camera installed. By the way, that servicing mission also put in new hardware. But comparing the two, cannot remember what galaxy this is. Any takers? It's not the Whirlpool. I know that, but it's cool nonetheless. But you can see it's before and after. After the optics were fixed, and with a more advanced camera. And so in July of '94, this is a kind of a big day for Hubble, a big day for pretty much our species. This was the first time that any of us saw a collision of 2 astronomical objects. So we basically have Shoemaker-Levy 9 giving Jupiter a black eye. And yet, anybody actually see Jupiter or any of the signs or photograph it or take a picture of it back then? All right, we got one. Awesome. Um, One of my favorite objects in the night sky. So in December of '95, NASA released this iconic image of the Eagle Nebula, or the Pillars of Creation. Then later on in 1996, this was the amazing piece. This was a huge risk that the controllers took and pointed Hubble for 10 days at a seemingly dark part of the sky. Remember, there are thousands of basically requests to use Hubble time. To spend 10 days looking at nothing, that's a big risk. You get fired for that. But this is what they got back. And approximately, 1,500 galaxies. And what was this? The eye, basically the area is as the size of a dime seen from 75 feet away. So an absolutely iconic picture that was taken. Then we have a second servicing mission. So this was, this was SM2. They actually put in the infrared camera and a few other things. All right, boss. Yeah, no, no, no. Oh, okay. All right, thank you. Woo. Second servicing mission. And then, so this was interesting. So at this point, Hubble actually went into what we call safe mode in 1999. And this is when basically the 4th of its 6 gyros actually went offline. And until this point, you needed at least 3 gyros to work. 5 minutes. Thank you. Otherwise, you can't point the telescope. Now, remember, this thing's moving at 5 miles a second. You need gyroscopes to keep this thing pretty steady and pointed at objects. in terms of, for any of you astrophotographers, if you think your mount has difficulty guiding or is, yeah. In December of '99, the third servicing mission comes up, and this is literally, if we look back, this is almost a month before or after. Sorry, this is November of '93. Goes into safe mode. Perfect timing. They went ahead and actually pushed the servicing mission forward. You'll see this is servicing mission 3A. So they basically took servicing mission 3, split it in half, what they could actually do as quickly as possible. And Discovery went up, fixed the gyros, installed 6 brand new ones. The fourth servicing mission happened in 2002 aboard Columbia. And basically, again, just continuing to upgrade it, put in better cameras, making sure that it's able to continue to do the amazing work that it was doing. Then, unfortunately, actually, no, I take it back. Sorry. So this is the basically the new ACS camera, and some amazing pictures captured. I love the mice galaxy. Galaxy. All right. Yeah. Um, that yeah, that's a hard act. That's a hard act to follow. Um, all right. So where were we? Timeline. All right. So we had a picture of our some amazing galaxies, and then February 1st of 2003 had another loss of a shuttle. This time Columbia during reentry. At that point, that 5th servicing mission was canceled. So SM5 canceled. So far we've got SM1, SM2, and SM3A have gone up. So they'll basically now there's 2 more actual flights, but technically it's a servicing mission and a half that's left. Um, So this time in 2004, they actually went and did the Hubble Ultra Deep Field. And I don't know the specs on exactly how much time was spent on here, but this is obviously, it's an amazing, amazing piece. And if anyone's ever seen, there's a documentary that Barbara Eden actually does a voiceover for, and that was for the Ultra Deep Field. Amazing, amazing. Uh, uh, Documentary, and actually is able to zoom in and does this kind of 3D fly through through the extreme deep field, or through the ultra deep field. And then what was very interesting, so obviously we've had some issues with gyros before. In 2005, basically they start operating, or they start learning how to operate Hubble on just 2 gyros, knowing, hey, we've got 6 good ones, and when we do our final servicing mission, we'll have 6 brand new ones. But how do you keep as many as possible in reserve? So in 2008, the 100,000th image or observation is taken. And this is part of the Large Magellan Cloud. And then we have, sorry, then Hubble enters safe mode another time, and this is not necessarily a failure with the reaction control wheels or anything, but the ability to actually send transmissions down to Earth. I believe they were able to reset that without a servicing mission. But regardless, a servicing mission went up the next year, and this is the 5th and final one. So this is SM4, and basically new batteries, new gyroscopes, pretty much as they could, gutted it and made it as new as possible. So when we think about this, that was quite some time ago. So we're looking at almost, what is that, 18, 17 years ago? Not a single servicing mission since then, and it's still running. It never went more than, just a few years between servicing missions prior to this. So in 2011, its 1 millionth science observation is made. And I'll jump through these. The first Nobel Prize was actually awarded also in 2011 for discoveries using Hubble data. And its 10,000th paper was actually published that same year. And then they decided, hey, let's see what we can do, and we're gonna do the Hubble Extreme Deep Field. So in this scenario, they actually used a bunch of old data and compiled it to create the following image. Again, called the Hubble Ultra Deep Field. Um, Now, this is the part that actually blows me away. Okay, I take that back. This is a ultra deep field, again, updated with ultraviolet data. And then it takes its iconic Pillars of Creation photo, basically after almost 20 years. And this one just blows me away. This is the one, if you actually see, a lot of times they'll do a kind of a side-by-side of JWST and Hubble, and this is the picture they use a lot. I wish I could get that kind of view out of mine. Not quite working. 2017, Hubble is actually studying the TRAPPIST system and is able to basically study the atmospheres of those exoplanets and confirms that you've basically got these Earth-sized exoplanets, and the two innermost are rocky. This is the one I was mentioning. So this is the largest kind of deep field image it's ever taken, the widest, half a degree, which is kind of funny when you think about it. I think, most of us are easily taking images well in above a degree, 2 degrees, etc. But I think I couldn't make it out, but I think this might be Markarian's chain. I'm not sure, but this kind of looks like it to me. But again, not exactly sure. Um, in 2019, basically water vapor detected on a exoplanet in the habitable zone around its star. Um, and at this point, in March of 22, it was it's basically a detection. This is the furthest star detected at 12.9 billion light years. Not galaxy, star. Um, Now, in this case, not too long ago, NASA's actually now has changed how it can point the Hubble Space Telescope only using one gyro. How that works, I have no idea. But basically, able to keep those reaction control wheels, those gyroscopes, kind of in inventory, is going to hopefully extend Hubble's life into the 2030s. So some of the kind of groundbreaking discoveries, I put this 20 out there, but some of them I just thought are pretty amazing. I'll just kind of highlight them. And oh, come on back. Sorry. So February of 95, first time to detect oxygen basically in the atmosphere of an exoplanet. First instance of detecting a planet's atmosphere evaporating into space in March of 03. And again, this is before we had data from Kepler and TESS and all those other things. So it's pretty remarkable. Detection of water vapor on exoplanets in the habitable zone. So it's absolutely amazing what Hubble has been able to do. And then, of course, detecting water vapor in the plumes off of Europa. So hopefully 2027, is it, when Europa lands? I'm trying to remember. Sorry, can't remember. But hopefully, sorry, when Europa Clipper lands. Well, yeah, I'm sorry, orbits. Maybe it should land. No. So it was Hubble. And one of the things that many of you may have gotten involved, and we'll do a show of hands real quick. Did anybody participate at all in the 30th anniversary Hubble Night Sky Challenge? So got a few people here. So it was actually a really, really neat thing to do. I mean, there's no way that we could ever get close to being able to image or capture things through an eyepiece or sketch what Hubble can see, but it was really enjoyable to try. It actually also helped get me further along in completing my Caldwell Awards, so that was good. But the challenge was to image or observe at least 4 objects based on the provided month. And if you completed all 12 months, then you get the big Hubble Award. I believe there also was one, I didn't know if it was just one observation required in a month to get just the monthly one, or there was still 4. I can't remember. But yeah, yeah. And then we did some outreach events. So I began a YouTube series on these, and it just got harder and harder to do. So I got 3 into it, and then couldn't do any more. Life gets in the way. But here's what I captured. So here are a few of my objects. So the first, an oldie but a goodie, the Orion Nebula. So it's a diffuse star-forming region located in the constellation of Orion, about 1,500 light years from Earth. And my image, not so bad. So mine are all EAA, just to set it up. So there's no post-processing. And it's basically what I saw, how I was able to manipulate the image live. Most of these are somewhere between 5 and 10 minutes worth of total amounts of stacking. But it's basically what was on my screen at the time I hit save. So this one was taken with my 11-inch and using a ZWO cooled camera. So in this case, it's a little less than 10 minutes, shot from Stanton River State Park. A lot of them will be, and it is an international dark sky site. So Hubble's image, okay, it's got something on mine, but that's 520 exposures, and some were taken from the ground too. So, but nonetheless, it's an amazing image. So yeah, no comparison. Hubble wins that round. Okay, this one I actually really liked. Hubble's variable nebula. So it's a reflection nebula located in the constellation of Monocerotis. I've got monocirrhosis of the liver. 2,500 light years from Earth. And my image, there we go. We'll zoom in a little bit, but again, with my 11-inch, in this case, it's about a little less than 8 minutes. This is shot from Apex in my front yard. We'll zoom in a little bit. I love how it actually looks like the butt of like kind of the front part of a cigarette and the smoke's coming off of it. Now the Hubble image, okay, it's got a little more detail. But cool image nonetheless. You can definitely tell it's the same object. Yeah, I was on an angle at home. So Caldwell 39, located in the constellation of Gemini, also known as the Eskimo Nebula or the Clown Face Nebula, located, like I said, in Orion, 5,000 light years from Earth. My image, this thing is tiny. This thing is very, very small. It's less than, I think it's less than 2 arc minutes. I mean, it's tiny. Shot with my 11-inch. Believe I shot it at home. Yep. This is just under 10 minutes. So we start to see a little detail. I'm not seeing the clown or the Eskimo, but yeah, there we go. That's Hubble's image. And so this was just after its second servicing mission. So yeah, can't quite get the detail, but I think we can tell it's the same object. And then Cobalt 63, planetary nebula, also known as a helix nebula. This is also known as the Eye of God, or most recently, the Eye of Sauron. I'm not a Lord of the Rings fan. Astro, not Middle Earth nerd, astro nerd. And 650 light years from Earth. So here's my image. Not bad. Not bad. Yeah, thank you, Elon. So this was shot from Staunton River State Park. And here's Hubble's. Yeah, yeah. I know, but when you zoom into this one, the details you can see are amazing. So, which sadly are not available in mine, but you know, not too bad. Yeah, we won't talk about my bloated stars or potentially slightly out of focus, or even the fact that I've got a lot of vignetting in the corners. But hey, it's EAA. All right, that's it. So I really enjoyed it. Any questions on Hubble? You get some of the.
Oh,
All right, we're gonna wait for the microphone to get to you.
okay, I
So,
didn't see who had their hand up.
We've got two in the front row here.
Oh, okay, sorry. Okay, thank you. Dana's going to turn the lights up.
Any explanation as to why the colors are different between your image and Hubble's?
Yes, so mine is using a one-shot color camera. So I'm stuck with literally which pixels are being excited in the Bayer matrix. Hubble uses what's called the Hubble palette. So it's a series of monochromes. So its wavelengths are separate. So yeah, it's definitely different. Another one up here.
Oh,
Right.
okay. I thought it was something else here.
Yep.
It's like an auction. Someone drew it.
Thank you.
Okay.
I was just wondering how the path now between James Webb and the Hubble, and not only those, but the ground-based
Yep.
stations. How do they all work together?
Excellent question. So James Webb only looks at the infrared spectrum. It'll do a little near infrared, but also the interesting thing is that as light waves propagate through the universe, they're actually propagating through space that's expanding. The result is that you go from these higher or kind of basically kind of more squished wavelengths of light. So you have visible light, maybe even some ultraviolet or gamma rays. But as they move throughout the universe, they get stretched out and they get stretched into infrared. So there's a lot that Hubble can't see or couldn't see because it's already in the infrared. It's already been stretched outside of what its basically its cameras could see. So James Webb was never designed to be a replacement for Hubble. It's just the data that the astronomers want to see, most of it's already in the infrared. And they already have telescopes that'll pick up in ultraviolet and the X-ray and things like that. And we're at a point now where with adaptive optics, you've got ground telescopes that can pretty much compete with what Hubble could do or can do. So. Mm-hmm. Yep. So, yeah, he was saying he was at McDonald. Yeah, so that's at is it near Fort Bend, Texas? Is that the one? Or Fort Davis? Sorry, yeah, Fort Davis. Yeah, it has the actuating or the actuators on the back of the mirrors that basically adaptive shoots the big lasers out and measures the atmosphere. So, yep.
Okay. So you had mentioned that they replaced the gyroscopes, all 6 of them, I suppose?
Yep.
Yes. So they are operating on one gyroscope at a time. In other words, they're letting the 5 rest. Is that
Yes,
what's
exactly.
going on?
They
Okay.
keep it basically in reserve, and then
And
what I
then-
don't know is, are they kind of like, assigning one to each day of the week, I don't know. But in other words, they're basically they're sharing the load or they're saving it. And so when one gyroscope finally goes, and technically they're reaction control wheels, but they're, in my mind, they're gyroscopes. But yeah, so now they're actually on one at a time. What I don't know, and I couldn't find out, are how many are currently still working. I could not find it anywhere.
Hey, Mike, it's Doug. So also one thing on the with respect to the images coming off the Hubble mirror versus JWST is that JWST was actually specifically designed so that both of the scopes could complement one another. So basically the JWST's images stack perfectly on top of the images from Hubble. And so it's basically the two instruments are complementing one another.
Yep, absolutely. So what I'm showing up here right now is just you basically are kind of in a similar vein. You were basically taking data from Hubble combined with other telescopes, and yeah, you're able to do so much more with that. And and I think you can liken that to technically what some of us might be doing when you've got old images of a particular object. You take new images and you kind of reprocess all that data again. So again, kind of making the best of both worlds.
Hi, so there's after this is James Webb's you talked about. Are they not launching another one, another telescope in space here in the next couple of years?
I don't know for a fact, but if they are not, if anything, I think if anything's on the drawing board, it's most likely going to be a replacement for spectra like in UV or X-ray or something. Because I think it was Spitzer that is no longer online as of 2019. I can't remember. So, but yeah, I have serious doubts that they will ever put up another space telescope that works in the visual light rays.
They're working on Nancy Roman right now.
Yeah, but Nancy Roman's a ground base, right? Yeah. Oh, sorry, yeah.
Roman. Yeah.
The Roman telescope is it?
How are they keeping the Hubble Space Telescope in a stable orbit? Are there thrusters on there, or is the orbit going to be degrading over time?
There are no thrusters on that. Every servicing mission did boost it.
So it's not been boosted for 19 years then?
No, yeah, exactly. So it will eventually crash. Although I would love to see a rescue mission and bring it home. But without a shuttle, that's really not possible. Maybe Elon can figure something out.
So there's one called, like you said, it's called the Roman,
Okay.
the Nancy Grace Roman Space Telescope, and it has the same mirror as the Hubble, but it's more powerful. So
Interesting.
yeah, that's going to be in a couple of years. Or remember.
Interesting. Okay. It doesn't say what spectra of light it's going to look at, or
Infrared. Yeah,
infrared. Okay.
infrared.
So you had mentioned that the Hubble has only looked at 0.1% of the sky.
0.1%.
Is that because it just happened to focus on one part of the sky, or it just took that many years?
Hubble's field of view is incredibly narrow. So they would study certain bits of it, but it basically
It just took
it just took that long. Versus the Vera Rubin telescope, that I want to say is able to capture the entire night sky every few nights, 3 nights. Yeah. So obviously there's a difference in resolution, and but yeah.
I have a quick question too, then I'll give this to him. So in 2030s, when it's done, is it just going to stay up there as space junk? Are they going to try to retrieve it? What are they going to do?
So it will eventually degrade. I don't know exactly what they'll do. I did not get that far in the research. My assumption would be that they would have to robotically put something on it to slow its orbit and control control the orbit. But yeah,
Yeah, I was wondering if they'd
It's-
like send up a space shuttle or just kind of, we'll see.
that would be cool.
That would be
I
cool.
I would love to see that in the Smithsonian or something, but that's a very expensive proposal.
I imagine it is. Did we have any questions on Zoom before I give this to Dean? Yeah.
All right, well, let's give Mike a hand.